Hello and welcome back to another lesson at the Computing Guy. Today we'll be looking at binary and denary conversions, number systems. So, generally speaking, as human beings, we rely on something called the decimal number system. However, as you might have read elsewhere, computers operate in binary. Now, decimal numbers need to be converted into binary form before computers can process them. And today we'll be looking at the conversions between the two number systems. But before we can do that, we need to understand how decimal numbers systems work, and you're probably quite familiar with it. So in a decimal number system, there are 10 digits, 0 through to 9, and the value of each decimal place is determined by multiplying the previous place value by 10. Now, as you probably learned in school, you had the units, the tens, the hundreds, and the thousands column. Now, this is exactly what we use when we're trying to gauge what we're doing with our denary numbers. So the value of the number 156 is placed in this table here. We've got 6 in the unit column, we've got 5 in the tens column, and we've got 1 in the hundreds column. So that is the makeup of the denary number system and how it works. Something that, like I said, you're probably quite familiar with. You just might have forgotten about it over the years as you've progressed through your education. Now, the next thing is we need to understand, how do we convert binary into denary? Now, as we're aware, binary consists of only two symbols, 0 and 1, on and off. The worth of each binary position is found by multiplying the preceding position's value by 2. And in an 8-bit binary number, the different positions you need to be aware of from right to left are 1, 2, 4, 8, 16, 32, 64, and 128. Now, each position can only hold a 1 or 0, and converting a binary to decimal number involves adding together the place values that all have a 1 in them. Now we're going to be looking at an example number. The number is 11101011 from left to right. Now, binary numbers consist of only zeros and ones, as we are aware from the previous slide, and we're going to figure out what's going on. So before I explain the workings out, I think it's important for us to just note where the ones are. So I'm just underlining the ones because this will come in handy later on. So we've got a 1 in the 1 column, the 2 column, the 8 column, 32, 64, and 128. Now, what we need to do in order to convert this number is we need to times every instance of the column being on or a 1 being there by the placeholder above. So if you see below, I've got 128 times by 1 plus 64 times by 1 plus 32 times by 1. I've put the 16 and the 0 there just so we know that we're skipping them out. Obviously, as you get more comfortable, you might not necessarily need to add that into your working out. Then you got 8 times 1. You got 0 times 4. That should be 4 times 0. 2 times 1, and then 1 times 1. So what that proceeds to do is it gives us all the values we need to add to convert the number. So we've got 128 plus 64 plus 32 plus 8 plus 2 and plus 1. So 128 plus 32 will give me 160. 160 plus 64 will give me 224 plus the 2, 226 plus the 8, 234 plus the 1, 235. So there you have it. That's an example of how we convert a binary number into denary. So remember the steps. You fill out the table. Okay, you underline all the ones or highlight all the ones, whichever one works for you. Times the ones by their corresponding value placeholder values, and then add up all your numbers. We will now look at how we can convert a denary number into binary. So we've got our column set up and we've got the number 102. So what we need to do, much like the binary version, we need to go through column by column. And in this case, we're going to look at 128. Now, 128 is bigger than 102, so we can't use this number. The next number is 64. So what we're going to do is I will write my working outs here. So we've got 102 minus 64. Just using my mouse. So Please do forgive me if my handwriting is not the best. So 102 minus 64, off the top of my head, that gives us 38. So we've now got 38. Where we've got 38, we now look at the next number. That's 32. So 32 is smaller, so we can use that again. So 38 minus 32, that will give us the number 6. Now we can't use 16, we can't use 8, we can use 4. So 6 minus 4 will give us the number 2, which make the rest of the steps fairly straightforward. So now we're on the number 2. 2 minus 2 will give us 0. So once you've got to the number 0, you've kind of used all the different numbers you could along the way. So in this case, it's 64, 32, 4, and 2. Now these numbers will have 1s in their column. So we've got a 1 in 64, 1 in 32, 1 in 4, and a 1 in 2. The rest will proceed to have a 0. So a 0 there, a 0 in the 16, and a 0 in the 128. So our number 102 in binary would be 0, 1, 1, 0, 0, 1, 1, 0. And that is how we convert a denary number into binary. Now we're going to look at the steps, just so we're aware of the actual procedures. So to convert a decimal into binary, we begin by subtracting the largest possible placeholder value from the decimal number, and we insert a 1 into the place value position. Then we subtract the next largest place value number and insert 1 into corresponding column, and we continue this process until we find the reach the number 0 rather. And then we fill in the empty place values with zeros. So there you have it. That's how we convert denary numbers into binary and binary numbers into denary. Thank you for taking your time to listen to this lesson. Please like, comment, share, and subscribe, and we'll see you in the next one.